In this video, we're going to review some of the skills with integers that you've learned in previous courses. And you might ask, why is this important to me? Well, integers are necessary to be able to evaluate an expression or calculation. Maybe it's so that you can win a roll up the rim to win prize, or maybe it's so that you can get the correct answer on a math test. Being able to work with integers also means you can decide if your answer is reasonable. If you find out on a test that you think the cost is -$3 per ticket, that doesn't make a lot of sense, and maybe you need to go back and check your work. Understanding integer skills also allows you to connect to new learning, in particular one of the major focuses of this course, which is algebra. We talk about how to use algebra to model real life and solve problems related to real life. Algebra is something that we build on for future mathematics topics in courses that you'll take after this one. And for all of us, algebra also allows us to practice logic and reasoning. So that's why it's a really big part of this course. And algebra itself is based on a couple of big ideas. Those ideas include understanding number relationships and being able to use patterns, and that math works the same way each time. Being able to work with integers ties into both understanding number relationships and into seeing how math works the same way each time. Another way that integers are important in this course is to be able to algebraically manipulate equations and expressions. We do a lot of solving, and in order to get the right answer, sometimes we have to be able to work with integers. So let's get started. We know that our positive numbers show up on the number line looking like this. And in fact, in high school, we tend not to put the plus symbols in front of positive numbers to save ourselves time. We know that on a number line, the further to the right a number is, the larger its value. Now, the negative values show up on the opposite side of the number line. They're off to the left. And again, since we know that farther right means a larger value, this would tell us in comparison that even very small positive values, like +1, are larger than negative values, for example, -3. An easy way to remember this is to think about a thermometer. -10 degrees is warmer than -20 degrees. Now, when we think about negatives, when we're doing calculations, it's often helpful to think of negative as opposite. So we know that 12 added to 8 is 20. If we have 12 added to -8, that negative means opposite. So instead of thinking of this as addition, we're going to think of 12 subtracting 8 and get the answer of 4. On the other hand, if we have 12 subtracting 8, negative means opposite. So instead of subtracting, we're going to think about adding 8. 12 adding 8 is 20, the same way that 12 subtract -8 would be 20. When we're thinking of integers and negatives as opposite, it's sometimes also helpful to think of as a light switch, turning the switch on and off. This is especially helpful if you see more than one negative. So if we look at multiplication, we know that 2 multiplied by 3 is 6. This is a positive value. If we put a negative in, it's like flicking the light switch. So now instead of being positive, we have a negative value. And this is the same whether the negative is in front of the brackets, or with the 2, or with the 3. If we have one negative in the multiplication, our answer will be negative. On the other hand, if we have 2 negatives in the multiplication, the first negative flips the light switch to the negative position, and the second one flips it back, so that -2 multiplied by -3 isn't equal to -6, it's actually equal to +6. This is also true for division. We know that +45 divided by 9 is +5. If we put one negative flips the switch to negative, and our answer will be negative, whether we're dealing with a negative in the numerator or the denominator. But if we have 2 negative symbols, we're switching once and twice, and in fact our answer is positive. Another really common problem that students have is when a negative symbol shows up in front of a fraction. Where does that negative symbol go? It might be helpful here to think about using your calculator. +10 divided by 3 is 3.33333333, 3.3 repeating, and we show that with a little line, over the 3 after the decimal. If you ask your calculator about negative 10 divided by 3, well, that's negative 3.3333 repeating. If our answer is negative, we have one negative somewhere in the fraction. It could go in the numerator. It could go in the denominator. It really doesn't matter which, so long as we don't put a negative symbol into the numerator and denominator. Two negatives would turn the switch off and on again and give us a positive answer. One other thing to consider that is a very common source of error for students is integers that are paired with exponents. And notice here that there's a difference between negative 3 squared and negative 3 in brackets and then squared. In the first case, we think just about plain old 3 squared, which is 9. The negative symbol means we're talking about the opposite of 3 squared, and the opposite of 9 is negative 9. When we add the brackets in there, now the squared tells us that we're taking negative 3 and multiplying by itself. We've reminded ourselves earlier in this lesson that a negative multiplied by a negative is positive, so in this case, we end up with a positive 9. Another common question students have when dealing with integers is, why won't my calculator tell me what the square root of a negative is? In order to answer this question, we have to think about what a square root does. We know that adding and subtracting are the opposites of each other, and multiplying and dividing are opposites, and exponents and roots are opposites of each other. So if 5 squared is 25, the square root symbol undoes that squaring. The square root of 25 is 5. So if you're thinking about the square root of negative 121, you're saying something squared is negative 121. Something squared means that you're multiplying by itself. Let's see, 11 multiplied by 11. Well, that'll be positive 121. We want a negative answer, so we need one negative in there. But then we're not multiplying the exact same thing by itself, and if we multiply two negatives together, our answer is positive. There just isn't a way to multiply something by itself and get a negative value. At least, not yet. That's saved for a later math course. But for now, that covers some of our important skills with integers. Our goal to this point is to be able to work with and to make sense of integers as you study algebra in this course.